Hi class, sorry I can't be with you today. To ensure that you don't miss the lesson, I recorded a flipped video that you're going to actually watch in class with the help of the substitute. So at this point you should have already written down your homework because the homework is posted on the homework board in our class. The homework is textbook pages 574 through 575, numbers 1 through 8 all, and numbers 22 and 23. And for numbers 22 and 23, you're going to show your work as done in class using WSE. The warm-up. At this point, you should have already turned in your homework calendar from marking period 3 to the substitute. Make sure your name is on it. Next, we will do a binder clean out. If you have not taken the Unit 4 test, please do not participate in the clean out since you might need these papers to study. But if you did take the Unit 4 test, which most of you did prior to break, you can spend the next 5 minutes cleaning out your binder. As a reminder, you should recycle or take home all your warm-ups, your homework, classwork, and notes, and you should keep all the papers and keepers, which should be your tests and quizzes and your PARC handouts. So please spend the next 5 minutes. If you need a rubber band, help yourself to the shoe rack and use the recycling bin in the back of the classroom. At this point, the substitute teacher can pause the video for the next 5 minutes. Now on to the lesson. So you should have the notes in front of you. With these notes, we need to define 4 key terms in order to continue with today's lesson. And we're going to draw some arrows. So parallel lines, we've definitely have heard this before, and we're going to draw an arrow down to this definition. Parallel lines are 2 lines that never meet and are always the same distance apart. So these 2 arrows here are parallel. They are always going to be this distance apart, and they will never crisscross if they go on forever and ever. A parallelogram is this guy right here, and it's a quadrilateral with 2 pairs of parallel sides. So side AD here is parallel with BC, and sides AB are parallel with DC. Perpendicular lines, and that's straight across. And I think of perpendicular lines as making a T, and in this case an upside down T. And you can see the symbol for parallel lines is right here. That line AB is parallel with MN. MN. A quadrilateral. So quadrilateral is underneath parallel lines and onto here. And it is a closed polygon with 4 sides. So you're very familiar with certain quadrilaterals like squares and rectangles. A parallelogram is a specific type of quadrilateral, but also this is a quadrilateral. That it has 4 sides and it is closed. What I mean by closed is it's not open. So this is going to be a little sloppy because it's on my computer, but 1, 2, 3, 4. That is the definition of a shape that is not closed. Yeah, it has 4 sides, kind of. Like I said, it's difficult with a mouse, but since this is open, it is not considered a quadrilateral. So I'm going to have that go away. Okie dokie. So we're going to start off with our introduction activity. So we have 3 parallelograms at the top of your page. We have X and Y, X and Y, X and Y. Remember, area is measured in square units. So what are the values for X and Y in each parallelogram as shown above? So let's just take a look at this first shape here. It's a rectangle and also a parallelogram. And we can see, we can count at the bottom here that we're going to count boxes, not lines. So we have 1, 2, 3, 4. So X represents 4 on this shape, and Y, remember, we're going to count boxes, not lines, 1, 2. So we have, let me make this a little skinnier. We have, for this one, X is 4 and Y is 2. For this one, X is 1, 2, 3, 4, and Y is 1, 2. 4 and 2. And for this one, X is 1, 2, 3, 4, and Y is 1, 2. So you can see that X is consistently 4 units, and Y is consistently 2 units. What is the area of each parallelogram? So we're going to count the squares. This first square is the easiest to count. So here we go. So we have 1, 2, 3, 4, 5, 6, 7, 8. For this one, we have 1, 2, 3, 4, 5, 6. And I'm going to visualize that this piece is kind of tucked right here. That if I were to chop this off and tack it on here, it would fill in this gap. So we had 6 so far and 7, 8. So that's 8 as well. And I'm going to visualize the same thing here. I'm going to pretend that this triangle is tucked into this white space. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So the area of each parallelogram is 8 squares. Make a conjecture. Try to come up with a formula that may work to find the area of a parallelogram. Explain what you notice. So I notice in these 3 parallelograms above that the first one's the easiest, it's a rectangle, but that the base is flat and the height is flat, but the height here happens to be a side of the shape, one of the sides. Here the height is inside the shape, and here the height is really inside the shape, almost in the middle. So it doesn't matter. The height could be on the outside or it could be tucked inside, but it doesn't have to be the side of the shape. And the base is the flat bottom. So 4 times 2 is 8, 4 times 2 is 8, 4 times 2 is 8. So the formula is area equals base times height. And you might come up with another reason, and your answer doesn't have to match mine exactly, but this is what I was thinking. The height doesn't have to be an outer edge to the shape, but can be counted within the shape, as long as it's at a right angle with the base. And remember, a right angle is 90 degrees. So y and x are perpendicular, 90 degrees. Y and x, perpendicular. Y and x, perpendicular. Constantly making a T. All right, so we have 2 parallelograms here. Remember, the height of a parallelogram is the perpendicular distance between 2 parallel lines. So we have, we're going to take a look. First, we're going to find the area by counting the squares. So let me, oops. If I were to take this triangle here, and if I were to tuck it in this space here, then I could count. And so let me count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, we're pretending this is filled in. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So when I counted, I had 30 square units. Now, using the formula, there we go. So using the formula, I'm going to take a look. And my base, I'm going to look at down here, 1, 2, 3, 4, 5. So for the base, I'm going to think of that, oops, as 5. And now the height is going to be the distance. So this is one base, and this is the other base up here. And so it's the perpendicular distance. So the height here is going to be 1, 2, 3, 4, 5, 6. So my height is going to be 6. So using WSE, I'm going to have area equals base times height is W, area equals 5 times 6, and area equals 30 units squared. Wonderful. Now let's take a look at this parallelogram. I'm going to first go by counting, and I'm going to, it's kind of hard to count diagonal. So I'm going to visualize that this triangle is kind of chopped off and then tucked into this white space here. So I'm pretending like this is one cohesive rectangle. Now let's count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So when I count, I have 32 square units. And when I use the formula, get rid of all these dots here. When I use the formula, I'm going to see the base as 1, 2, I'm going to look at this bottom space right here. Let me switch over to highlighter. 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8. Oops, I'll go red. There we go. My base is 8. And my height, remember, I don't care about this diagonal because it has to be 90 degrees. So my height, I'm going to pick right here because it needs to be the perpendicular distance between the two bases. And this line is one base and the line up here is the other base. So my height is going to be 1, 2, 3, 4. So my height equals 4. So A equals B times H. A equals 8 times 4. A equals 32 units squared. Below, draw 3 different parallelograms with a base that is 5 units long and a height that is 4 units long. What is the area of each parallelogram? So I'm going to get started here. And so here we go, I'm going to try to use red so it pops out. So the height, the base has to be 5. So 1, 2, 3, 4, 5. And my height is 4. 1, 2, 3, 4. And this is my other base. That's 5 across. And 1, 2, 3, 4. So that's my first parallelogram. Yours could be different. There's many correct answers, but this has a base of 5 and a height of 4. So the second one, base of 5, 1, 2, 3, 4, 5. And my height, I'm going to put here. 1, 2, 3, 1, 2, 3, 4. And I'm going to start my second one. 1, 2, 3, 4, 5. So this parallelogram also has a base of 5 and a height of 4. And now this last one, 1, 2, 3, 4, 5. And I'm going to do it here. 1, 2, 3, 4 is my height. 1, 2, 3, 4, 5. And then I'll connect my two bases. So all 3 of these parallelograms have a base of 5 units and a height of 4 units. The area would be A equals B times H. 5 times 4, 20 units squared. Alrighty, here we go. This is the classwork. So at this point, if you don't have it, if the substitute can hand it out, that would be helpful. And you should copy at the top. A parallelogram is, let's define it from scratch. It is a quadrilateral whose opposite sides are parallel and congruent in length. So we need to label the height of each parallelogram. Remember, the height must be 90 degrees to the parallel bases. So there's actually, it depends on which orientation you're looking at the shape. But for this one, I'm going to say the base is this bottom piece. So I'm going to draw a line here. My base is this bottom part. And the height, I'm going to draw it here. And remember, the height has to be 90 degrees. And so for this shape, I'm actually going to see the base as being one of these side pieces. I'm going to look at it sideways because I think that's It's helpful for me to see the base as one of the flat sides. The height is going to be seen as, see it. Okay, and the height is, I'm gonna label the height just right there. So the height is 90 degrees with the base. The formula for finding the area of a parallelogram. At this point, it should be really clear. Area equals base times height. So this class practice at the bottom, you are going to use WSE to solve. So at this point, the substitute can pause the video and give you about 5 minutes to do these two problems, and then he or she can replay the video to go over the answers. All right, wonderful. Now that you've had 5 minutes or so to work on these problems, for the W part, A equals B times H. The base here is 9 feet, and the height is 4.8 feet. This 5.8 feet is unnecessary. So oftentimes they will give you numbers. I don't need to know the diagonal side length. It's not necessary. So I plug in 9 for the base, 4.8 for the height. Remember, the order doesn't matter because multiplication is commutative. And when you do multiply 4.8 times 9, you get 43.2, and the units are feet squared. For this problem here, they give you the area. They give you the height. They do not give you the base. So A equals base times height is the formula. I'm going to now substitute what they give me. They give me 56 for the area, 4 is the height, and we don't know the base. So that's why I just put in X. I need to isolate X. I need to solve for the variable. So right now 4 and X are being multiplied, and the inverse operation of multiplication is division. So divide by 4, divide by 4. This cancels out right here. And 56 divided by 4, you should get 14. And for units, it would just be straightforward centimeters. And I got that from the figure above. So the answer for X is 14 centimeters. Wonderful. At this point in the lesson, if you have any questions, you can raise your hand and the substitute can try to answer your questions, or you can quietly ask a partner. But if all is well, you may start your homework in your textbook. Good luck, and thank you so much for behaving. I will see you tomorrow.